For this assignment, we're going to be looking at calculating acceleration. And if you think of a car, acceleration is how quickly it speeds up or how quickly it slows down. So our calculation is for average acceleration, which is what we're going to be focusing on, is the average, not the instant acceleration or deceleration, because that would be more complex. We're going to be taking the change in velocity, which means we're going to take the final speed or final velocity minus the starting velocity or starting speed, and we're going to divide that by the time that it takes to go from the final to, or from the starting to the final, the change in time. So if we have a car that's traveling 50 miles per hour and increases to 65 miles per hour over 5 seconds, what is the average acceleration? So we need to figure out the 50. So the V initial or V start is going to be 50 miles per hour because that's what they started out at. And then our V final is going to be 65 miles per hour. And our time equals 5 seconds. Now we need to put that into the equation. So we're going to have, now that I have the information, I can cover that up. So acceleration equals the change in velocity, but we have to take the final minus the initial. And that's really important because that will help us determine whether it's accelerating, which means speeding up, like the speed's getting faster, or if it's decelerating, which means the speed's getting slower. It's going to slow down. So we need to take the final minus the initial, and we're going to divide by our time, which is 5 seconds. So subtraction, that does not change the labels at all. So we're going to have 65 minus 50, which is going to give us 15 miles per hour. And we're dividing by 5 seconds. So we're going to end up with 15 divided by 5 is 3. And our label is going to stay, like we can't cancel anything, so it's going to be miles per hour per second. So what that means is every second that that car is driving, it's increasing 3 miles per hour. Now let's go ahead and do another one. So if a toy car is pushed down a ramp and is going 10 feet per second at the bottom, what is the average acceleration if it travels for 2 seconds? So we've got V final, let's go V initial, V final, and time. So our V initial, it doesn't tell us what the initial is. Well, it's saying it's being pushed down a ramp, so it's starting from a stop, which means the V initial is going to be 0, and we're in feet per second. Okay, then we've got V final, which is going to be our 10 feet per second, and our time is 2 seconds. Okay, so then for acceleration, we're going to have our final 10 feet per second minus the initial, which is 0 feet per second. And we're going to divide that by time, which is our 2 seconds. Okay, so now 10 minus 0 is just 10. So I'm just going to go straight to dividing by 2. So 10 divided by 2 is 5. So our A is 5. And then our label, we've got feet per second divided by seconds. So that gets a little tricky. Feet per second. And then we're dividing by seconds. So one way we can look at this is it's going to be feet per second per second. But because we have per second, we can actually make that feet per second squared. It sounds a little goofy. This is where it gets a little complicated when you're doing labels. So I just want to go over how you go from feet per second divided by seconds to getting feet per second squared. So you were always told that if you divide, you can also multiply by the reciprocal. So the keep change flip rule. So if I do that, I'm going to keep my feet per second. I'm going to change my sign. And this is truly S over 1 right here. So what I'm going to do is I'm going to make that 1 over S. Okay. So what happens then is you get feet times 1, and 1 is just a placeholder. So it's going to be feet, and then we've got seconds times seconds. They're both in the denominator. So it's going to be feet per second squared. So this explains why our label ends up going from feet per second, which seems weird, to being feet per second squared. Last problem. If a soccer ball is launched at 25 miles per hour and comes to a stop after 5 seconds, what was the average acceleration? And truly they could call this deceleration because we're going from 25 to 0. So my V initial equals 25 miles per hour. My V final equals 0 because it's coming to a stop, miles per hour. And my time equals 5 seconds. And we want to know average acceleration. So we're going to take A equals, we want to make sure that we're taking the final minus initial. Now this is extremely important when you have something slowing down, because if we have final, the 0 miles per hour, minus the initial 25 miles per hour, that number is going to be negative. Okay, and then we're dividing by 5 seconds. Okay, so 0 minus 25, that's easy. That's just a negative 25. It does get a little trickier when you have a number that's lower and a number that's higher here. Or, sorry, a number that's both numbers. It gets a little trickier, so you need to make sure that you're putting them in the proper order. So, negative 25 divided by 5 is going to give me negative 5 miles per hour, and we're dividing by seconds per second. If you have any questions, please let me know, because I know especially with the labels get complex just because it gets harder to picture what's happening with them.